Hello everyone, today again in this video we'll discuss another kind of conversion from CFG to PDA. What are the another type of conversion? The conversion is there are two types. One is conversion from CFG to PDA. So one by accepting by final state by final state, accepting by final state, accepting by final state. Another type is accepting by empty stack. Right, this has been already discussed in my previous video. I have done 3 to 4 problems on this acceptance by final state. Okay, so today I'll take this problem, acceptance by empty stack. So let us see this problem. There's a grammar as given for this problem. That means a WCWR. What is the grammar is in this? S gives ASA or BSB or C. This is a grammar as given. This grammar convert into PDA. How this you have to convert? We already seen conversion step in the previous video for accepting a by final state, right? Today this have to done by acceptance by empty stack. So there is, before jumping into this type, let us understand by accepting while doing a conversion from CFG to PDA, that is accepted by final state. That means any given grammar in that, any grammar in this form, right? That means it's a GNF form, grabbage normal form. But accepting a by empty stack, you need not convert given grammar into GNF. Is it in the any raw form, right? Any grammar is in that format. So you can directly convert, need not to convert to the GNF. You can directly start conversion from CFG to PDA. So that's a reason I have taken this. I'll show this two kind of conversion from CFG to PDA. First conversion I have done it in previous video. If those who are not watch that video, please you have to go about my video blog and you have to check out that conversion from CFG to PDA, so that you can watch before watching this video. Then you can understand clearly what are these two types of conversion, right? So let us start now conversion. So in this corresponding PDA, acceptance by empty stack. Let us given there are 3 rules on S. There are 3 rules on S. S gives ASA. Another rule is S gives BSB. Another rule is S gives C. Right? So what is the first conversion? Let us understand this. Any grammar is in the form of S gives AS or S gives BSB or S gives C. So in this case directly you have to write like this: delta of Q comma epsilon S. That is a start symbol. You can convert what are the production of S, you will be in the same state. So okay, then what is the production as given by S? One is SAS, another one is BSB, another one is QC, right? only you have to push it onto the stack directly. This is a push operation, right? So whatever this S production, just you have to push onto the stack. Okay, I hope you understand this. Let us see other this one push operation over. The next you have to pop it, because all the productions have pushed onto the stack. Then you have to be pop them. Then what are the non-terminal symbols here? A, comma, B and C. Then you have to pop whenever A is on top of the stack, input is A, pop it. So that's a operation. Delta of Q comma A, this is input, this is the top of the stack, then you have to pop it. Similarly for the other case also. So input is B, top of the stack is B, and pop it. Then another case is, so C is also terminal symbol, C is a input, top of the stack is C, pop it. So all this over, one is push is over, all this is a pop is over, then you can write the PDA. So write the PDA means you have to describe BM. There are seven tuples will come, you have to define them. So what are those? Look at this. The first it is capital Q. Capital Q you have taken only for the Q only. In this case you have to Q. Sigma is a input alphabet ABC. Then delta is already you have defined, this is a transition function. These are the transition function, right? You have taken this all this transition function. And tau is, so there is another notation. This is a stack alphabet. Yes, small ABC, all of them you are pushing onto the stack. What is the next one? Is there will be initial state, that is a Q itself. Okay, then what is a stack is? Stack is, so here it is Z0, that is a stack alphabet is Z0, is a top of the stack, Z0 initial stack, initialize the stack, that is Z0. In this case S will be the Z0, and there is no final state is required, because there is, you are making an empty by empty stack, right? So you are making that as acceptance by empty stack. So that's a reason there is no final state in this case, no final state is required. This is so easier than to previous technique. So you need not to convert the any given grammar to GNF if not there in the GNF. In this case, you can directly push irrespective of the production, push onto the stack. Whenever the terminal symbols are there, you have to keep on popping it and describe finally these 7 parameters. That will be clear. I hope you understand this. Understand this. Is there any doubt? Please you have to comment on the comment section. So let us move to the next problem. Guys, please you have to understand this problem. There are multiple productions here, right? One is S gives AB, S gives AB. Another is A gives A or epsilon. There are two rules on B, A, and B again it is, there is a two rules on B. So this is a given production. So obviously when seeing this production is not in GNF form, you need not to make this, convert this into GNF. Directly you can start converting by technique accepting by empty stack. Okay, as usual you have to start that like this. Solution is, there is a input is empty, just pushing S onto the stack, S production onto the stack. I push it, right? You are in Q state, there is no input beginning, and S production, push it onto the stack, that is S production AB will be there, you are pushing onto the stack. There is another production in the given, there are two rules are there. This is also similar, look at that. There is right, that is also similar. Okay, just look at this. Okay, that is also similar. Look at this. There is another production is A gives A gives epsilon. Look at this. Again you are not taking any input, looking at the A production, pushing it onto the stack, and another rule is there, at the same time pushing epsilon to the stack. Okay, similar for B as well. Look at that also will be there. So here it is also like that, there is no input, that just you have to top of the stack is B, pushing that B production onto the stack. That means B gives A, B, B, and B gives epsilon. So that means entire production of B will be pushing onto the stack, then it is epsilon as well. Then pushing is over. When pushing is over, then again you have to start writing a M. Start writing M. What is that M? Look at this, how this will be work. Now just before writing M, you need to write the this is the push operation, then this is a push operation, then you have to write the pop operation. The pop operation will be like this, pop operation. Then what are the terminal symbol is A, B, right, and epsilon as well, right. So here whenever A comes, pop it, B comes, pop it, right. There is epsilon is it is not part of a symbol of input alphabet, then you can leave it as it is, because nothing is, just it is representing a empty string. You need not to push it and pop it. Okay, so there is define M. In this case, you know, as usual, there is a Q is only Q. This will be the only A comma B. Then this will be the entire this. Okay, tau is only S, A, B, and small a and B. This is a stock alphabet. These are the stock of alphabets. Q naught is Q and Z is S. There is no final state. Understood? Now I'll show it in the animation. Look at this. This is a Q, A, B, C. This will be the transition. Then is a stock alphabet S, A, B. Even S also, a stock alphabet S is producing, right? Okay, A, B, C is also leaving it. In this case, you have to be ordered it. If the by mistake as not shown here. Okay, this will be the S, A, B, and A comma B, stock alphabet. These are the stock alphabet. Okay, another case is Z is the stock symbol, initializing a stock directly, and there is no final state at all. I hope you understand this. There are two problems and done on this technique. This will be the whichever technique is easy for you people. That means it is a depending on the mass, and mass is very less. Then you can take this situation and acceptance by empty stack. You can go ahead directly. Need not to convert this grammar into GNF. If the mass has given 10 mass and all, you have to choose the first technique, that is my acceptance by final state. Any given grammar is not in GNF, you have to convert that into GNF. Then you can start converting it. That all will be explaining in my previous video. Please you have to refer it. Thank you.